Hello everyone, my name is B. Geetika, currently pursuing BTech first year in JNTU University Anantapuram from Computer Science and Engineering branch. Today's our topic is operations on deque and its applications. Let's start our session. First of all, what is double-ended queue? Double-ended queue allows elements to be added or removed on either of the ends. That means inserting at front and inserting at rear, deleting at front and deleting at rear positions. We have two types of deques: input restricted deque and output restricted deque. First of all, what is input restricted deque? Elements can be inserted only at one end and elements can be removed from both the ends. It is called input restricted deque. And what is in output restricted deque? Output restricted deque, elements can be removed only at one end. Elements can be inserted from both the ends. It is called output restricted deque. Here Q used as in stacks and in queues. deque as a stacks when insertion and deletion is made at the same time, same side, then it is called deque as a stack. Now deque as queue. When elements are inserted at one end and removed at other end, then it is called deque as a queue. Here there are mainly four operations in deque: inserting at beginning and inserting at rear position, deleting at front and deleting at rear position. First of all, inserting element at front position. Inserting front is a operation used to push an element into the front of the deque. For example, an array with elements 1 to 7, when 0 is pushed into the array elements, then the array elements becomes 0 to 7. This is called input insert front. Now algorithm for insert front. First of all, start. There are three conditions. First is when front is equal to 0 and rear is max minus 1, that is size minus 1, then deque is full. Or front is equal to 0 and it is not possible. Other than these cases, front is equals to front minus 1, that is front is decrementing towards the previous elements. Then deque of front is equals to that element. Now inserting at rear position. Insert rear or insert back is an operation used to push an element at the back of the deque. For example, an array with the elements 1 to 7, when we insert an element at the rear position, then the array becomes 1 to 8. This is called input insert back. Algorithm for inserting at rear position is start. If front is equal to 0 or rear becomes max minus 1, that is size minus 1, then q is full. If rear equals to size minus 1, then it is not possible. Other than these cases, rear equals to rear plus 1. That means rear is incrementing towards next elements, that is of deque of rear is equal to that element. This is the algorithm for inserting at back position. Now inserting are completed. Now deleting at front position. Removing front is a operation used to pop an element on front of the deque. For example, an array with elements 1 to 7, when we remove an element at the front, then the array becomes 2 to 7. This is called removing element at a front position. Now we'll see algorithm for removing an element at a front position. First of all, start. If we have three conditions. One is when front is equals to minus 1, then q becomes empty. Or front equal to rear, then front equals to rear equal to becomes minus 1. Other than these cases, front is incremented by a value towards the next elements. This is called algorithm for removing at front position in double-ended queue. Now we'll see about removing the element at back position. That means deleting at rear position. Removing Rare is a operation used to pop an element on rare position of the deque. Now the algorithm for deleting an element at the rare position is if rare equal to -1, then the deque becomes empty. If front is equal to rare, then front and rare both becomes -1. Other than these cases, rare is decremented by towards its previous elements. This is the algorithm for removing at a back position. Now, what are the applications of deque? There are few applications of deque. They are the a steel algorithm implements a task scheduling for several processors. Multiprocessor scheduling. The processor gets the first element from the deque. When one of the processor completes execution of its own threads, it can steal a thread from another processor. It gets the last element from the deque of another processor and executes it. These are the main applications of a double-ended queue. There are one more other applications of double-ended queue, that is undo and redo operations in software applications. This is the brief explanation about a double-ended queue and operations in double-ended queue. And one of the application is palindrome checking. Deques are partially useful in checking for palindromes because they can add characters from both ends and compare them efficiently. By utilizing a deque, we can push characters from a string into the deque and then pop from both ends to check for equality, ensuring we can handle cases with a minimal time complexity. And in summary, deque presents powerful operations for both accessing and managing data with remarkable efficiency. Their applications in palindrome checking or job scheduling and sliding window problems illustrate their versatility and effectiveness in handling complex data structure challenges. These are the brief explanation about double-ended queue or deque. Thank you.